All right, pre-calc. In the second part here, what we're going to do is just try and verify each. So we're trying to use our algebra skills with a lot of these different identities that we are aware of. So first thing is, if it doesn't look like something that you are already familiar with, then try and change it. All right, so secant, well, that's 1 over cosine theta. And cosecant, that's 1 over sine theta. Cotangent is cosine theta over sine theta, plus tangent would be the inverse, right? Sine theta over top of cosine theta. Well, it doesn't look like it was very helpful, but what I notice is my common denominator would be sine, cosine. Cosine theta, sine theta. Could have used a little more space there. So as I distribute back to the left, what's going to happen is I'll get cosine times sine on the top and the bottom, so it turns into 1. And then when I distribute to my next term, the sines cancel out, so I get cosine squared theta, and cosine will cancel out here, so I'll get sine squared theta, and how about that? So we're in pretty good shape. In our second one, what I notice right here is we have conjugates, right? We can work with this as kind of like thinking of difference of squares, right? A squared minus b squared is going to give me a plus b and a minus b. So I can put this together by multiplying. So I'm going to get 1 on top. On the bottom, we'll FOIL this together, and I'll get 1 minus plus. I'm going to get minus cosine squared x. Notice we changed x and theta out here. And that's going to give me cosecant squared x. Well, the next thing I notice is, remember we had sine squared theta plus cosine squared theta equals 1. Well, if I subtract the cosine squared theta over, I would have, so now I have 1 over sine squared theta, or x, equals cosecant squared x. Well, that is truly the definition, so we have verified that those shall be the same. Okay, so just using some of those different strategies as we take a look at them. All right, what do we got here? So really just having some fun with some algebra here. I know it sounds really geeky, but having some fun with some algebra here. So what is tangent? Tangent is what? Sine of x over cosine x equals, is there anything we can rearrange here? All right, so what I can do here is, now that I have set it more up as a fraction, right, sine and cosine, I'm just going to bring the right-hand side down the way it is. And then I'm going to cross multiply. So we're going to end up with sine squared x cotangent squared x equals cosine squared x. Well, what's cotangent? Cotangent is going to be, so I'm going to have my sine here. Cotangent turns into cosine squared over sine squared. Take a look at that. So we're able to get rid of those. So now I have cosine squared x equals cosine squared x, and I think we agree that that is true. All right, not sure why I have this note in here, so I'm going to kind of strike it out here, but often finding a common denominator is going to be a good thing. But what I can do here is cross multiply again, and notice we have conjugates. So I'm going to end up with secant squared x, or theta, minus 1 equals tangent squared theta, okay, which is exactly one of our identities. So we're in pretty good shape there. Not scrolling very good tonight. There we go. All right, so we get a little practice here. So if you want to pause it and try it out, you can do that, and then we'll bring it back and make sure we have the same thing. So sine of theta, remember cotangent is cosine theta over sine theta. So what we can do is put that over 1, so we can see that this can be reduced to get cosine theta. So we're verified there. Got another one of these cross multiply. So hopefully we're in good shape after that. Negative cosine squared x equals sine squared x minus 1. Okay, so we got a little bit too much going on here, but remember our idea is to make it look like one of our identities. So if I add cosine squared x to this side, and I'm going to add this 1 back to the left, so I should end up with sine squared x plus cosine squared x, and it equals that 1, which was the identity that we wanted, so that we can get where we want to be. All right, let's get a couple ideas going here. So we get 1 over sine squared theta. Let's get this thing mixed up here. So this is 1 over tangent squared. Well, that's actually sine squared theta over cosine squared theta. Okay, so if we work on this being reciprocal, then I can actually say that this becomes minus cosine squared theta over sine squared theta. So then I do have a common denominator, and it equals 1. So what I'll do is put that numerator together. So 1 minus cosine squared theta over sine squared theta. And it equals 1. I can put that over 1 so we can cross multiply. And watch what happens here. We got 1 minus cosine squared theta equals sine squared theta. All right, so if I add cosine squared theta over, look at where we're at. We're right back to our identity. All right, one more. Hopefully you're getting the idea of trying to get everything into sine and cosine. A lot of these go along with the same process here. So sine's going to stay that way. Hopefully they're getting used to the idea that tangent is going to be sine over cosine. And it equals 1 over cosine minus cosine of x. All right, so now that I have kind of a common denominator with everything going on here, let's go ahead and multiply the whole thing to get rid of it by multiplying by another cosine of x. Okay, so our very first left-hand side here, this could become sine squared, and we'll cross out our denominator here. So sine squared x, and then we'll end up cosine x divided by cosine of x is 1, minus cosine of x times cosine of x is cosine squared of x. And again, we're going to add cosine squared x to the other side until we reach an identity, which is what we're after. Okay, so really using a lot of algebra skills, getting rid of fractions, doing all these things until we have reached the point where we want to be.